Well, welcome everyone to, I think, the fifth time we've done a summer webinar with Steve Will on behalf of formerly Help Systems, now Fortra. I'll talk quickly about that in just a bit, but we're on the IBM I in 2023. It's the 35th anniversary. How exciting for all of us who have used this technology over the years to have something that has really stood the test of time and yet modernized along the way to keep up with your infrastructure needs and your application needs. So we're really honored here at Fortra to have Steve Will with us again to share his expertise around the IBM I technology. As you know, we did have a name change back in November. We went from Help Systems after 40 years to Fortra as a name. It wasn't an easy decision. It was a marketing decision and a board level decision at the Help Systems company that we had become more than just this I-series company. Now, IBM I is very important to us. It represents a good portion of our business, but we wanted the world to think about us as a serious cybersecurity company for the entire world. We know that that's the #1 thing on everybody's mind, and we wanted to make sure that you all knew it, and hence that's the reason behind the name change. So with that said, Steve, I think it's time to get talking back on IBM I.
Sounds good. Yeah, let's introduce ourselves and what we're going to be doing here. Hopefully you all know both of us. I'm Steve Will. I'm the Chief Architect, the CTO of IBM I. Was made a Distinguished Engineer last year. And I'll be talking a bit about my history and my path through this industry during my presentation. But Tom, not only does Fortra sponsor this presentation every year, but Tom and I work together a lot throughout the years and certainly run into each other at events and conferences and so on. So Tom, why don't you tell people what you do, and then we'll get on to my part of the presentation.
Excellent. Well, Tom Huntington, I'm our EVP of Technical Solutions at the Fortra company now, and I get involved in, the fun thing I get to do these days is I probably talk to 10 individual customers on IBM I every single week about what they're doing, where they're going, what's happening in the market, and everything centered, around what we do here at Fortra. And that's been really a great learning experience to see where people are going with the platform. I'm also an IBM Power Champion, have been that now for 8 years, and it's related to the IBM I Marketplace survey that we do and have been doing now over almost nearly a decade. So let's turn it back to you, Steve, and we'll talk some more in a bit.
Sounds good. All right, well, thanks to everybody who has joined or who's listening after the fact. We are, as we've already mentioned a couple times, celebrating the 35th anniversary of this platform. And this is one of the charts we built to kind of show our heritage. I'm going to be going through several of the eras that are represented on this chart, but I'm starting things a little bit differently this year than in prior versions of this presentation. You will still get some of the architecture stuff that I've talked about prior, but I'm going to kind of fold it into this celebration and why we're celebrating. And I'm starting this year by talking about IBM I from a business point of view, and you'll kind of see why I certainly expect that you all understand IBM I is important to your business. You run, maybe you're a partner, maybe you're an ISV, and you sell your solutions, your services, but most of you are probably people who are running your business using IBM I. Well, I want you to understand that this business that you are participating in is a business that's a worldwide business, and this business has been growing over the course of the past several years. During what we think of as the pandemic and post-pandemic quarters, we have grown almost every quarter in the last 10, and we have, if you combine it all together, grown double-digit during the last 2.5 years. And that's important for the whole marketplace to understand, because if you're a business person, if you're trying to decide what you ought to spend your business money on, you look for parts of your business where there's growth, where there's opportunity for growth. And that is the case in terms of how IBM looks at investing its money. So as we were approaching the 35th anniversary, we weren't even quite there yet. One of the cool things that happened within IBM is that one of our IBM executives, representing a whole bunch of IBM executives, paid tribute to IBMI and the IBMI community at an event that we did. This is an internal event. So I can't show you all the slides that were associated with that, but Tom McPherson, who is our Chief Information Officer, Chief Financial Officer, sort of combined for Power Systems, was in front of thousands of IBMers. And he was talking about ever since he joined in the role that he's in, and he's been in the role now for about 18 months or something. He said he's never seen such a passionate community about a product in IBM or outside of it as he sees from the IBMI team. He said the word love comes up with IBMI, and he just doesn't hear that in technology. It was a great thing to have him say in front of other people, and he mentioned as an example of how this love is shown by the community, that it's tattoo-worthy love. Now, a lot of you have been part of the community for a long time, and so you understand what he means. There are people out there in the world, there's Jesper, who have tattooed themselves because of their love for this platform in its heritage days, AS400, for example. And so when he mentioned that, I think this was back in March before we started doing the big anniversary celebrations, we said, okay, he mentioned tattoos. Now there are people all over IBM who know tattoos. We're gonna follow that theme. So to celebrate the 35th anniversary, one of our team members partnered with somebody to create a tattoo around the IBM i35 thing. And we were sharing these IBM i35 tattoos, the love of IBM I, represented by that heart with the arrow through it, and then the 35 years. And we use this a lot at various events. I even used it with Bill Starkey on the 35th anniversary event that I did in Dallas. So anyway, it was fun. No,
These
those are not
fantastic, Steve. Unbelievable. I love
yeah,
it.
they are not permanent tattoos. We didn't go and get permanent, but these lasted for days. They were quite a chore to take off. Anyway, it was fun to have them. So the actual day that we celebrated, of course, was the 21st, the 35th anniversary of the initial launch of the AS400. And we'll talk about that in a little bit, but I just wanted you to understand just how broad and wide this community was that celebrated. Now, before the 21st, we did some celebrating at the events that we had, like, for example, the common user group Power Up Denver, et cetera, the IUG in Northampton, the large users group that we did in Rochester, okay? But on the 21st, we celebrated all around the world with all sorts of different events, some of which were run by user communities, some of which were run by partner communities, some of which were run by our ISVs and so on, all around the world doing various things. So I hope that anybody who's listening to this was part of it. If you weren't, most of the material that was presented to everyone, because we had a worldwide broadcast that we did 3 different times for the time zones around the world, all that stuff is recorded and out there and available for you. But there has just been so much focus, so much passion, so many people who are willing to give up some time on the 21st or after the 21st in certain parts of the world, whether it was Japan or Tel Aviv or whatever that did it afterwards. We actually surpassed 10,000 people participating in these events. This is amazing, folks. We know that there are, tens of thousands of companies using IBM I worldwide. And of course, they have their own people. So it's, thousands and thousands of people. But to be able to get 10,000 folks who focused on some of their day on celebrating with us, it's really humbling, and it's also exciting. So Tom, yep, absolutely. The Common Power Up Conference in Denver, even though we hadn't gotten to the 35th, people were excited and ready to celebrate. And then on that day, we gathered together just thousands and thousands of people, and it was great. So that's the platform we live in. That's the platform you're part of. I want to talk a bit about how we got to be where we are. So again, this is the chart that we built to show kind of the pedigree. But as we were preparing our 35th anniversary material, we created some stuff that people may not know, or maybe you know it, and this will just remind you of it, to let you know kind of how we evolved throughout the years. And it really started in many ways long before this. And so I've built you an IBM I before Power, the prehistory that led to AS400 and IBM I. Everybody knows there's a mainframe, right? And so the mainframe existed, but very shortly after the mainframe entered the market, IBM said, you know what, we could do better than this. And so we're going to create something that we're going to call the Future Systems Project. And it was going to have remember again, a follow-on to the mainframe. That's what existed in the marketplace at the time. Okay, a new architecture that was going to be a super complex instruction set computer. It's going to have multiple abstraction layers. They invested in this for a long time, 4 years, millions and millions of dollars. But what it turned out to be was overambitious. It had no path for people who were on the 360 to move forward to this thing. And there were 3 systems in the Future Systems Project being developed. There was a large system in Poughkeepsie, a medium-sized system in Endicott, and a small system in Rochester, Minnesota, all of which were under this Future Systems product umbrella. Now, I'm telling you this story not because I participated in it, but because I've heard about it so many times, okay? During these years, I was 10 years old. So anyway, I wasn't part of this, but that Future Systems product that was the small system inspired the System 38. It was during the Future Systems time frame that some of the fathers of the AS400 were initially hired. And so those concepts, for example, that Frank Soltis brought from his PhD work got inserted into the System 38. They fit very nicely into that Future Systems project idea about how to do things. And so the System 38 came into existence. But at the same time, in the same cornfield in Rochester, Minnesota, another group created this thing called the System 36. And the idea behind the System 36 was, we're not going to take any of this future systems stuff. What we're going to do is try to create something that would draw business applications to want to run on the platform. And we're going to make it super easy to use. And from a business point of view, System 36 was way more successful than the System 38. It did, in fact, draw a lot of software vendors to create packages for it. It did create an ease of use that made it super easy for non-computer people to use a computer. And we sold way more System 36s than we did System 38s. And both of them were being developed at the same time in Rochester by what it turned out to be competing development teams. Well, ultimately, another ambitious project started happening in the System 38 family. Something called Fort Knox was created to try to converge the System 38, which, while it wasn't as successful in terms of the number of customers as the System 36, had clearly proven itself architecturally to be something that we wanted to invest in as a company. Okay, so they tried to take that System 38 architecture and converge it with the mainframe in this project called Fort Knox. Now that Fort Knox project proved again that there was no way that we could actually replace the System 360 at that time with this Fort Knox thing. But there were pieces of that that showed that this System 38 architecture could be evolved to do something other than what it had started with at the beginning. And so the Silver Lake project was created. We've got 2 fairly successful systems being developed in Rochester. Let's put these people together and find a way to bring that ease of use and that business application focus into an architecture that was built to survive any sort of transformation that might go on in the IT industry. And so that became the AS400. I know a lot of you have probably heard of the Silver Lake and have heard of the System 36 plus System 38 thing, but I thought it would be nice to kind of put this in the context of how did we even get to that System 38 and what were the ideas that IBM had over time. Remember, this multiple abstraction levels, which is going to turn into the MI sitting on top of various parts of the stuff below the MI, that layered architecture. It didn't actually start with the System 38, but it was an idea that was going on in computer science at the time about how to create an operating system that could last through multiple changes in technology. Became part of 38, became part of Silver Lake, became part of AS400, and so then it became part of IBM I. Now, the key as they were putting the plan together for the AS400 was we do want to take the very best ideas from the System 36 success. System 36 had proven to the business that if you can appeal to application developers to create applications on your platform, you can be successful, even if you didn't have as forward-thinking of an architecture as the 38 had. If you appeal to the application developers, you will have a successful platform. So they said, okay, what does every application need to have in it? What is going to make our platform an application platform that people will want to create business solutions for? Well, everybody's going to have data and want to get not only out of the data what they need specifically for their application, but they're going to want to be able to secure it easily, not have to manage it very much. You're going to want to be able to secure things. And at the time, people were writing security into every application. What if we could create a base of security that every application could rely on so they wouldn't have to do that? What if you could make your operating system as flexible as possible so that if you have a small installation or a large installation, you don't have to change which version of the operating system you have? Again, for those of you who are more recent to the industry, you may not understand this, but back in the day, people would have different versions of the operating system depending on how many transactions you were going to do or how many customers you were going to have, et cetera. What if you could make an operating system where it didn't really matter? What if you could integrate everything that that application provider was going to need, not just access to data, but doing problem determination, being able to connect up to other things that you need to connect to? And then what if when you wrote that application, you were guaranteed that that application was going to run on the next version of the operating system and the next version of the hardware? Again, for those of you who are relatively new to the marketplace, that was not a guarantee that anybody else could provide. So the people creating the AS400 said, we're going to learn from the System 36, be a good application environment. Now let's apply the technology for this architecture that we want to create to that. And so when we get to the meat of this presentation, okay, we're going to see how IBM I AS400 was built to do that and then evolve that over the years. But before we get there, I do want to mention every one of you has come into this part of the IT industry, the IBM I series AS400 industry from somewhere. And so we'd actually like to get a feel for where you were and what your history was.
Thank you, Steve. And so we have our first polling question. During which era did you start using IBM I technology? Before AS400, the AS400 days, I-Series System I 2000 to 2008, and IBM I 2008 to today. And if you do the math on it, IBM I has been around the longest, right, Steve?
Yep, absolutely. Yep, but no judgment here. I'm just really curious to know, the people who are with us today, when did you start? When did you start learning this stuff? What we found over the several years we've done this is that we've gotten more and more people who haven't been around as long, and that's great because they get a bunch of education. But there's always a core set of people who will say, well, I was around when the system 3, that
Yeah.
sort of thing. So,
Or you don't go back far enough. I love
if
your
I,
comment. You were only 10 when they were working on the mainframe stuff.
yeah,
Myself, out of college, and guess what? I didn't know RPG or CL or any of the things, but I came from a college that taught COBOL, Pascal, Fortran, BASIC, and did it on HP technology. Or not HP,
uh,
yeah, no, Honeywell
oh,
technology.
Honeywell
That is
technology. Okay.
Honeywell technology, believe it or not. And started on a System 36 actually at an agribusiness company in the Minneapolis area, and did that for maybe 6 months, and then switched over to the System 38 platform. Worked for the corn milling, flour milling division that ran 10 System 38s around the country, and from that, we probably mowed down some of those cornfields in Rochester with the corn milling group anyways. But learned a lot about the whole internals of work management and how those things worked, and came over to help systems when the AS400 platform was announced, went to some of the parties, and kind of the rest is history. I've been with the Help Systems Fortra company now for the exact same anniversary as IBM, 35 years,
Oh,
which is,
cool.
it's pretty crazy. There's a lot of things synonymous in my life with that. So a few other personal events too, but nonetheless, that's my heritage, Steve. Like you said, everybody has a history of the platform.
Indeed. So let's see, how are we doing on polling? Are
Let me
we,
close it and share it. And looks like what 44% were before the AS400, okay, and 40% during the AS400 era, 7% System I, and 9%. So on the I series IBM I, 16%. So I want to thank you all for answering that polling question. Let me put that away and back to you, Steve, in the PowerPoint.
great. So as we said, and Tom, thanks for sharing your story. Everybody has a history. I just want to let you guys know kind of how I got here. I don't think I've ever presented this, at least quite like this, because I created this chart for this. Some of you may have heard parts of this. I graduated with a Bachelor of Arts degree in Math and Computer Science from Luther College, which is in Decorah, Iowa, which is 70 miles south of Rochester, Minnesota. It's my hometown, okay? I went after that to Purdue University, where I got my master's degree in about a year and a half, and then I joined IBM in January of '85. But I actually had a great experience at both of those places, and one of the things that it taught me was that people can learn a lot of programming languages if they're so inclined. I learned 8 programming languages at Luther. I learned 7 more languages at Purdue. I didn't use any of those languages when I eventually joined IBM. My point in mentioning this is not to brag about it, because I doubt I could program anything in any of those languages anymore without relearning them. But programming languages are programming languages, and that when you are learning computer science, you learn concepts and then you learn how things are done differently in those languages. And so it has always been part of my history to look at the different programming languages that are being used and understand, what's good about this language, what was this language trying to do, et cetera. That really has helped shape the way I look at application development and so on throughout the years. In any case, I got done, or I was nearly done with my master's degree, and I had to make a decision in the fall of 1984 about where I should go. And I had 3 real options, 3 job offers that were most interesting to me. The first one, of course, was IBM, and spoiler alert, I chose that one. Okay. But my other options were interesting as well. A really good friend of mine from high school had moved out to the West Coast of Oregon and was working at Intel, and I interviewed with Intel. I would have probably been a processor engineer at that point instead of a computer or operating system person. There was certainly some temptation there. But really the one that I was most interested in taking, but I chose IBM instead, so I was most interested in IBM instead, was working on the space station. CDW was a government contractor who was working on the operating system for what would be the space station. But remember, this is 1984, and the space station was not scheduled to launch until 1996. And they had an amazing task. They have to create operating systems in the various different computing technologies that were going to be part of the space station and have those operating systems talk to one another. And that sounded amazing, but it wasn't going to be for at least 12 years. And as it turned out, it wasn't for 16 years before it was going to get launched. And I wanted to be part of something that was going to come to market a lot quicker than that. It also helped that Rochester, Minnesota is only 70 miles from my hometown, so that was nice too. But anyway, I chose to join IBM in Rochester because we were going to be doing a brand new operating system that was going to launch a lot more quickly than the space station was going to launch. After doing the initial stuff that I'll talk about on the next page, I moved into pass-through. If any of you have ever used Display Station pass-through, I owned that for a while. Yeah. I got that running on the initial AS400 from the System 38 stuff. I was part of the team that rewrote the TCP/IP in the way it became part of the core kernel of the operating system. I moved into the security team. I moved into Apache, and I did a whole bunch of other things. But as I sort of already mentioned, while people tend to think of me as having been here forever, I haven't. When Dr. Frank Soltis got his PhD and was hired by IBM, which happened in the same year, I was 7 years old. So there were people around doing this long before I was. So how did I enter? How I entered was during that Fort Knox project. Remember I was talking about they were trying to take the System 38 architecture and apply it to the mainframe kind of thing. What they needed to do was to have 2 new processors come into existence. One of them was called the Iliad processor. In the original AS400, there was a service processor. It was codenamed the Iliad that got the main processor up and running and then communicated with that main processor to do various things across a bus, not a bus that you drive up. You know, this is a bus that carries data from one place to another. And this was between the Iliad processor and the processor that was the main processor. So I entered into history writing the communication protocols that ran on the Iliad to talk to the other, the main processor. And that stuff got used, even though Fort Knox got killed, that got used in Silver Lake AS400. So when you were touching the buttons on the control panel to bring up the system or to ask for it to do a dump or a debug or whatever, you were using the communication mechanism that I did between those 2 processors. So that's where I entered. And it's funny, I know. It's tough to talk about your less than perfections, but in graduate school, I took a networking course, and it was the only course I got a B in. And it's so amazing to me that I ended up then working in IBM as a data communications networking person, having these 2 processors talk to one another, and then moved directly from that into pass-through, where I made my name for myself. So anyway, I guess I learned better than a B once I finally got into it.
You know, the B students are the hard workers, Steve. Remember that.
That's right. Yeah. All right. So remember, I took us back to what were the requirements that the AS400 was trying to do. Try to be a bit application platform serving these particular application environment requirements. Well, we of course had DB2 and single level store managing the data from the very beginning. Right? An integrated relational database. Even though many of our first users did not use the power of the relational database because they were coming from systems where they used different sort of hierarchical systems, we had that from the very beginning. We had our object-based architecture, which was one of many architectural elements that allowed you to have security built into the platform from the beginning. We integrated into the AS400 all of the necessary stuff for doing printing and spooling and messaging and things that used to be middleware on other mini computers of the time, where you had to put a whole bunch of packages together. And then we, because we had come from the System 38, took advantage of the work management concepts of subsystems, layered over the top of that some of the ease of use that came from the System 36, creating environments for people to work in. And that all became part of this initial AS400 architecture that's still the IBM I architecture today. And of course, we had the technology independent machine interface, the thing that allowed you to compile a program once, okay, and then we would protect you as the hardware architectures underneath changed over time. All computer programs at that point were essentially compiled, unless you wrote assembler code. All code for real applications was compiled, and so it was all protected from the future. And of course, the AS400 had its own servers and storage that were unique to itself, and that's part of the evolution of the platform. Okay, but the operating system architecture above that protected people from knowing what those things underneath the covers were. Now, I was around then for the initial launch of the AS400 on June 21st of 1988. This is what it looked like outside of the buildings in Rochester. Most of the people at that time were wearing white shirts. It was a super, super hot day. I don't know what it was like where all the rest of you were, but it was one of those days in Rochester, and we only get a few of them a year where it was over 90 degrees. It was super hot, but it was really fun. And we had in Rochester several of the cast members of the TV show MASH. So a lot of you, based on your response to the first survey question, are old enough to remember the MASH television show. Well, we had several of the cast members there because during that time, there was an ad campaign as the AS400 launched, and it talked about how this new system was going to be based on integration, collaboration, and scalability. There was a series of commercials. Sorry, this is kind of a grainy screen grab, but there was a series of commercials where those MASH characters, sorry, the MASH actors, not the characters themselves, the MASH actors talked about how the AS400 was going to be good for the business. If you go out there and look for Google around, you can probably find the commercials that I'm talking about. We showed several of them in our in-person events. This is just a screen grab from one of them, but it was a fun time. We had to celebrate this new thing. It was the biggest launch I have ever been a part of as part of this this journey that I've been on. Anyway, so it was a really great time, and we did launch a system that could grow from the smallest systems out there running smaller environments with just a couple of people, all the way up to some very big systems that were actually encroaching on the low end of mainframe. But folks who had adopted the System 38 and were beginning to grow on that needed a place to go, and they moved into those Model B50s and B60s that could do the large things. Now, that architecture that we created was this layered architecture that, again, if you go back to what I said about future systems, people in computer science, not just IBM, but computer science, were saying it would be so wonderful if, instead of the operating systems that were being used at the time where everybody was so close to the hardware, if you could create an operating system that had layers so that you could write your applications without having to worry about what was underneath. And so we had that initial layered architecture. We had that object-based architecture, which helped to prevent people from doing things like pretending to be just an ordinary file, but actually being an executable program. Program objects in this architecture cannot be edited by people, whereas on other architectures, you could go in with an editor and change the code that was underneath the covers running on the machine. You can't do that on this architecture, etc. So we brought many of the concepts that had been thought of in academia to the marketplace with the architectural elements that we have. And that got people's attention right away, particularly in the area of security and data integrity, because even as we progressed into the 2000s, other operating systems that were competing with us still had the problem that their architecture did not prevent people from messing with them. And so they had to create all sorts of different techniques and tools and so on to protect what the operating system couldn't. Craig Johnson, one of our former product managers, created this chart that said, if you go and to a conference, a Windows conference, this is how many people will be speaking to you about how to deal with the security environment in Windows. Whereas if you deal with an AS400, IBM I-series crowd, well, we don't even need those things, right? We don't have to deal with it because the operating system protects us so much. And the storage model that interacted with our integrated database had been designed as this amazingly forward-thinking method of dealing with storage, where everything was going to assume to be one part or part of one big single address space, and let the system figure out, does it need to be stored on disk? If it does, where should we put it? There are still, most operating systems in use around the world, there are still people who are hired specifically to manage the balance of where things are stored on disk. You have to pay those people. They have to become super experts on how to do that. Now, while some storage area network technology is taking over that responsibility for some storage administrators, many people still are hired to do what your architecture has been able to do since the System 38 and does better over time, depending on the kinds of storage that are there. Now, that storage model spreads your data in ways that learn from how you use your data, where it should put it so that it can access it better. And we have an architecture under the covers that has a way of protecting that storage, because the pointers, the things that tell you where all that stuff is being used and is being stored and all that stuff, those pointers are actually protected by extra architecture. Every pointer that is used in programming and in data access actually has this extra thing, this tag that says, this data is not just bytes of data. It is a piece of a pointer to physical or virtual memory. And so you cannot mess with this, or you should not mess with this. Now, that was an amazing advancement in how to do programming. And so we created this architecture that dealt with, these tag bits. But over time, well, the initial programming languages that we produced with AS400 Release 1 didn't have a way for people to see what those pointers were. By Release 2, we introduced the C programming language. And the C programming language, as part of it, assumes that you, the programmer, are going to have access to those pointers, are going to manipulate those pointers. And so because it had access to pointers, we actually had to create yet one more way of dealing with that single level store than was available in Release 1 of the AS400. And I'll show you this is the why. Okay. Every program is running in main memory somewhere, and you have pointers that the application uses to the application available data, okay? But every piece of code that's running on the system that is operating system code also has pointers, okay? So if you're gonna give access to your C programmer to have a pointer that shows where in memory something is, what's to stop them from adding a bunch or subtracting a bunch from that pointer and ending up accessing the code that should be running the operating system? And if they can do that, what's to stop them from actually modifying that code? Well, we had to create a whole new security level to be able to allow us to then support something that would incorporate hardware protection, that would make sure that if somebody is running as a user, they could not add a bunch to a pointer and get into system space and system address space. So right away from the very beginning, we started doing the evolution of this architecture. What started out as a great idea needed to be advanced because computing was advancing. So we needed to be able to do that. Same sort of thing happened in our CISC to RISC migration. When the first AS400 came out, it came out with a 48-bit CISC processor. People, if you're new to technology, what was going on at that time in the 80s was there were 8-bit computers and there were 16-bit computers. We had a 48-bit computer, and we wanted to grow to a 64-bit computer. Everybody else was trying to get to 32. We were going to go to 64. But we had created all of this machine code underneath the MI that had to implement that 48-bit CISC processor, and we were going to move to this 64-bit RISC processor. We had to rewrite everything under the covers. There were hundreds and hundreds of people working 8, 10, 12, 15, 16-hour days for months at a time to rewrite everything below the MI so that we could sit on top of the 64-bit RISC processor. But once we did that, we were on the path to being able to do what we do today in Power. And we'll talk a little bit more about that. And at the time when we first introduced this AS400, the only way you could access us was direct attached 5250. But very shortly, it became clear that people were going to want to be able to manage this platform, use this platform using other things. And so almost immediately, I worked in pass-through, so I knew about 5250. Almost immediately, there were emulated 5250s and ultimately GUI simulated 5250s that we had to deal with. And so there was a whole architecture around how to do that. So I have taken you through some of the initial evolution. I'm going to take a little break here while, especially for my voice, while Tom gets a chance to talk to you, and I will come back in a few minutes and we'll carry on the evolution.
Very good. Just a few slides from the Fortra company, and thank you, Steve. I really appreciate the fact that you did add in that hardware protection and this the whole CIS to RISC transition was certainly something very unique in the industry, as other vendors in the market couldn't make the jump from various hardware levels to new hardware levels without people having to rewrite their applications. So we appreciate that. It allowed us to create a nice suite of products over the years to help out people with backup and recovery and HA. Document management is something that we do here at the Fortra company, centered very well around IBM platform. Cybersecurity, of course, is certainly on everybody's mind. We have a whole host of things, and I encourage you, if you're lacking in that tribal knowledge around how your security is set up, one of the things we do is a free security scan to help people out, and we've been doing those. We do 1 or 2 of those a day, I think. Monitoring, of course, we've been doing that for many years and alerting you, business intelligence around the built-in database that even people today I talk to outside this platform don't realize there's a built-in database with the platform. Capacity planning, certainly if you're looking to move to the cloud, purchase Power 10, and you want to know what you need, we do a lot of that for the entire world around Power, not just IBM, but we do AIX and Linux on Power. And of course, automation. Automation started the Fortra company with a product called Robot Schedule. If you can move on to the next slide. I remind you again about the IBM Marketplace survey. We are working on year 10. It will open up shortly after Labor Day in the US market anyways, but entire world around the 4th, 5th of September, sometime around there, we'll be opening it up. We hope that you can participate in it. It has been a valuable piece, not only for the Fortra Help Systems company, but IBM, and I wrangle with Steve's team about what questions to modify and add in every year. We try to make it a little shorter this year. Hopefully it will be. But as you can see, cybersecurity, modernizing applications, high availability, and IBM I skills. I'm always fascinated by the skills question and the number of people who, as I talk to them weekly, say, I don't know where to go for education. I'm baffled by that because the Google search will find you lots of things. And if you move to the next slide, one of the things we talk about on the next slide is way on the bottom, user groups. There's a lot of active user groups. And again, another good thing that happened as a result of COVID was that these are virtual. You can join any user group in the world. From a Fortra perspective, like I said, we have the 9th annual IBM I Marketplace Survey results that are available. We did a webinar, and we'll start the 10th here in September, October, asking the questions. The annual State of the IBM I Security Study is another thing that we put out there. Security, I think in some cases people think of IBM I as security by obscurity because there are systems out there we find that are very open, and you need to take a look at your security. Another thing to encourage you to do is we do a lot of executive briefings. We call them technology updates or tech updates, but basically we like to talk with you as customers about what's on your mind, what do we need to do better as a vendor, and how do we improve. We do those daily. And then finally, if you are buying new hardware, we do participate in the Solution Edition program. And if we move over to the next slide, we have several people on the Fortra team that are part of the IBM Champion program. If you are somebody who is active in the community, every year they take nominations for IBM Champions. It's not just for Power, it's across all of IBM. But we have three, myself, Brian Nordland, and Amneris Terrell from Argentina. Brian is on our Power HA team and leads some of our other development. And then Chuck is not a Power champion, but I like to always recognize him as he is leadership on our local Q user group out of the Minneapolis area. And if we move on to the next slide, the other thing we've been hearing in the market is cloud. And IBM I is a perfect technology for cloud because it's so scalable and it can be very secure that you can put on multiple instances of customers around the globe on the same server, even the same VM if you use work management type technologies. But anyways, we're thinking cloud. If you're wanting to talk about cloud and how you get there, give us a call. We'll help you out with that. If you move to the next slide, automation started the company. We started with robot schedule. Some of the newer things out there is we realized that most every IBM I environment has Windows, Unix, and Linux around side of it. We help customers with scheduling across from IBM I with Robot Schedule Enterprise. And then high availability. We have Robot HA, but we also work on Power HA on behalf of the IBM company. And the robot product line is very modular and used to help manage and automate the server even further so that you can run it totally unattended. Next slide, and we have the cybersecurity solutions here. I won't talk to each and every one of these. A lot of our engagements start with free IBM I security scan that we do at the bottom. We also help people implement single sign-on technology. But this last year, MFA, multi-factor authentication, we've heard a lot about that. We have a lot of people that are trying to protect PII data. We do native encryption on IBM I at the field and IFS level. If you have no security and you're concerned about your company that you didn't use all the great things that Steve talked about with object level security and stuff, Exit Point Manager is a great way to protect your database because we can put basically a firewall around those items on the system. And then another item we do hear quite a bit about is, I have to say, native virus protection. For IBM I, it's really all about your IFS. People do put things out there that have been infected outside the network, and they put a Windows document there. And then IBM I is a file server, and it is potentially impacted by ransomware. So recently we added in virus and ransomware protection into our relationship that we have on our PowerTech antivirus solution. That's probably enough for me, Steve, giving you a good break. Let's turn it back over to you to continue the IBM I 35-year anniversary discussion.
Okay, great, Tom. Thanks very much.
Yeah.
All right, so when I started my break, we had gotten to the point where we were starting to talk about some of the key advancements that needed to be made so that this architecture that started, you could think about it all the way back to Future Systems or System 38, but certainly started with the initial AS400, that we had to do evolution in order to continue to be the application platform that we wanted to be from the beginning. We have always recognized that when we need another architectural change to be able to allow customers to do what they ought to do, we're going to find a way to do that, even if it isn't natural in the original architecture. And so right around the year 1999, 2000, we decided we were going to pull in an environment because we were beginning to run now on the same processors as our AIX offering and on Power. This is pre the convergence, but we knew we were using the same processor under the covers. And so we wanted to pull an AIX environment in because there were so many pieces of code out there that were being written for Unix and then for AIX in particular, that we knew we could run side by side within IBM I next to our ILE environment if only we could get a kernel of AIX in. And so that's what PACE became. And by the time we got to the year 2007, it became clear that most of the open source stuff that was going to be done in the industry was going to be done on a Unix-like environment. by the way, at that time, yes, there was certainly Linux was growing, but at that point, Unix was the big X out there, right? And so we wanted to be able to take advantage of that to be able to bring open source technology. And we've been adding that. This has a couple of dates on it, right? 2007 for PHP, Ruby, Python, and Node. But basically any technology that's being done out there today that's open is going to run probably on a Linux platform, but because of that, and because it's similar enough to Unix's, we can get it running into IBM I with not very much work at all most of the time. This is about the same time frame as we got our letter name. Every system produced by IBM got its letter name, and we became I series instead of AS400 because we got the I for integration. Okay, and a key part of that integration, as we've mentioned a couple times, is our database. Our database had to grow over time as well. Okay, we started with an engine that had to take it into account that a lot of the applications that were coming to us weren't even using the relational capabilities, but we wanted people to move into that relational capability. And so we had to advance it over time into a much more robust query engine. But all the time, as we did this all the time, one of our key goals was to make sure that you did not have to hire somebody who did a lot of analysis on your database. We wanted to make sure that the database could do that itself. And so throughout the years, one of the big selling points of our platform has been you don't have to hire people to do database management the way you do on other platforms. And in fact, that database has become known for its flexibility and its ability to automate many functions. And there was a set of advertisements that were created in the early 2000s called the Laughing Boardroom. And again, I can't show this to you as part of this webinar, but if you go out and just Google iSeries Laughing Boardroom, I bet you can find this video. The Laughing Boardroom concept for the video was that some database salesperson comes in to talk to these guys to try to tell them all the cool capabilities that you can do with your database if you buy his solution. And they laugh at him because all of the things he's talking about are done by the database on their iSeries. Okay, you don't need to hire somebody and you don't need to perform those tasks. The system does it themselves. And so they end up getting a lot of amusement out of the fact that somebody's trying to sell them on the idea that they should go backwards, go to a database where you'd have to actually worry about that. So anyway, it is a key goal of ours to automate as much as we can, to learn within the database as much as we can about how you are using your data so that you don't have to learn that stuff and manage it yourself. Now, all of this stuff is happening in the AS400 I series at the same time as the business, the IBM business, is trying to find a way for AS400 and what was initially a workstation, an engineering workstation powered by the AIX operating system, how to combine those and converge those and get them onto one platform. Okay, what we wanted to do as a company was not have multiple architectures for processors and multiple architectures for the systems you built around those processors. And so the AS400 actually ran on a power processor way back in 1995. Okay, but it wasn't until 2000 that both of the platforms, P series and I series, could run on the exact same processor. And then it wasn't until 2008 where not only the processor, but all of the other hardware and IO and so on together could be exactly the same. So this marriage of IBM I and Power took place over the course of more than a decade. But the result of that, well, there are a lot of different results to that, but one of the results of that was we proved over and over again that you could have the hardware architecture change underneath you and you didn't have to change what you were doing with your compiled code. We could take care of that for you. And over time, you could take advantage of all the investment IBM was making in this power processor. So that power processor over time, over the course of that many years from Power 4, which is kind of in the I series time frame, all the way up to Power 10, that power processor then has been able to give you 140 times capacity growth without you having to change anything about the way your software is written or runs or whatever. It's really quite impressive. Now, it wasn't just the processor, but the processor was certainly helpful because over time we also had to do things to the operating system, again, to make it possible for today's applications to run on them. We had to create a multi-threaded environment so that we could bring on some of the more modern applications. And the one that drove us first to do multi-threading was Lotus Notes. We needed to have our platform have its own native way of doing emails so that not everyone was going to Microsoft's email or somebody else's email, and so that you could connect your notes and other Lotus applications to DB2. So we had to create a threaded environment. So that came about during this transition into the modern era where we could start taking advantage of what Power could do, because ultimately we knew Power was going to grow into a multi-core, multi-threaded environment. And if we could create an architecture within IBM it would have been I series, so i5 OS and OS 400, okay, to be able to prepare ourselves for that, we could really gain the benefit from it. Well, that started happening in normal traditional applications. People started writing multi-threaded applications like Lotus Notes, but a lot of you did the same thing. And certainly out there in the Unix world and the Windows world, people were doing that. But then also along came the web, okay? The idea that the interface to the platform wasn't going to be one specific 5250 or whatever platform you were on, its own specific thing, but there was going to be a generic kind of interface, and that interface was going to be served up to you sort of as you needed it, not writing a program to get information, but to create an interface which could reach down and ask for the current state of things. And so the HTTP protocol, the Hypertext Transfer Protocol, was created. And the idea was you were going to be asking your servers for information when you wanted to. And so we had to be able to respond to that. So threads were necessary, and we had to have very fast performing threads to be able to handle those requests, which ultimately became services, not just HTTP calls, okay? We also had to adapt to the kinds of software that were being written because of the World Wide Web, because of browsing. One of those links might be to go and get some information from a data, or it might kick off its own program. And if it kicks off its own program, it's probably going to need to use temporary storage. Well, single level store didn't have a very good answer for temporary storage. And so to sit alongside single level store, we had to create a whole architecture called TerraSpace, which is implemented within the operating system, but is not implemented in single level store. One of the concepts behind single level store is that at any moment, this storage that is part of memory is going to get put down on disk somewhere. Well, for storage that you know is always going to be temporary because it's always just running behind one of these applications that's coming in from the web, you don't need it to get written into storage. And so there's a lot that you can remove from the processing of that storage if you know it's going to be temporary. And that's what TerraSpace was. Most programmers on IBM I use TerraSpace without ever knowing they're using TerraSpace. Okay, because when they go and get temporary storage, unless they specifically are pulling it out of a single level store, it actually comes from TerraSpace. And everything that we do in the PACE environment comes from TerraSpace. And if you want that stuff, the information that's stored in TerraSpace's temporary storage, to be written to disk somewhere, you have to perform a write operation. Well, that's okay, because that's what everybody in every other operating system assumes anyway. And so those open architectures do that. That allowed us to move into an era where we could start now having our interfaces not be tied to this old, very limited architecture of 5250, but be able to be served by software that could do HTTP-like things. Java isn't HTTP itself, but it does HTTP-like things. It makes calls off like a web page does. And of course, webs can do that as well. So we had to advance our architecture to allow us to do that. And we had to listen to our customers on how we were going to advance even farther. And we do a lot of that. I have one specific example of that I have later in the presentation, where I'm going to talk about how we did a bunch of these advisory councils advising us on what we needed to do. But I also want to take you through a very, very quick version of what have we done in this Power era. This time frame from Power 4 to Power 10 today, what have we done that has advanced this platform to answer the requirements that come from this community? We're going to make a PDF version of this chart set available to you, so I'm not going to expect that you're going to be able to read all of this as I do it. What I'm going to do for you is kind of lay out a timeline across several of our technology sets. What you can see there is this is the Power 4 to Power 10 timeframe. So from 5.1 to about 7.5 and so on. Okay, we had OS 400 was what we were originally called. We became i5 OS in 2004. Then we became IBM I in 2008. Well, we as an integrated operating system have a lot of advancements that we have to make in a lot of different areas. For security, for example, we were the first operating system to create a digitally signed operating system so that you would know that everything that came from IBM is running your operating system and nothing from outside of IBM is running your operating system. There are a lot of other security things that got added between then and 2010, but this I just wanted to point out. Our database not only is a database, but it's a database that's secured and it gives you the ability to secure your data. And so this is when we added column level encryption, and then we did column level masking, and then we did authority collection for objects, including the database objects that are on your system. So throughout the years, we advance all of these things to become more of a platform that you would want to run an application on. Our database had to advance throughout the years. That query engine that I talked about that was much more powerful than the initial query engine got started back in 2002 and advanced over the course of several releases until you get to what you're at today. But we also had to be able to do things like decide if you've got data and you want it to be stored on faster storage and you want to tell the database to do that, you can do that. That happened in 2006. Or you want to start importing and exporting data using a protocol like XML that's in wide use around the industry for describing data. We want to be able to do that. Or you want to be able to ask questions of your data as if it were a different point in time, like 6 months ago or 2 years ago. Temporal support got added in 2016. All of this stuff gets added because we continue to want to be an advanced platform that does everything that you need to do as a platform. In storage, we started out as a platform that had our own unique storage, but over time we had to start using the same storage the rest of the industry was. And so we got our first SAN adapter way back in 2001. Then we had SAS storage, SSD storage, started moving the most active data out to SSD in 2012. And now we're doing NVMe storage. Okay, all of that again under the covers, being managed by our storage management single level store in DB2. Here are some things that aren't specifically related, just key things that started happening that you all might recognize as turning points or highlights. For me, it's a highlight. I became chief architect in 2007, and from there we had Power HA introduced in 6.1, technology refreshes introduced in 7.1. We were able to use those technology refreshes then in 7.1 TR4 to create live partition mobility, which is one of many things that allow us to be a cloud platform these days. All sorts of stuff has been added to this platform. For doing application development, we had our first 64-bit PACE AIX runtime environment back in 2001. Then we added free format SQL into RPG in 2006, and then finally got RPG free format in 7.1 TR7. So I guess that would have been, whatever, 2012. So continuing to advance new technologies, and we are able to manage the platform starting in 2008 with a web-based interface. People have frequently said we don't have a graphical user interface to manage our platform. That's simply not true. Ever since the web-based Navigator, we've had a way to do that. Plus ACS provides yet another way to do that. So over time, we've had a lot of advancements during that same time frame. And some of them are about how to use this platform in ways that people could only have conceived of back in the 80s, like, for example, doing virtualization, being able to set ourselves up to be able to be a cloud platform. In the 6171 timeframe, we created the ability to use IBM I in a virtual I/O environment, but also to create the possibility for IBM I to manage the I/O for anybody who's running next to us, particularly other IBM Is, so that you didn't have to have virtual I/O. And all of these capabilities have then allowed us to be able to be part of IBM's cloud answer. Today, if you want to run IBM I in a cloud environment that's provided by IBM, that's what the Power Virtual Server in IBM Cloud does. Of course, there are a lot of other ways to do cloud on IBM I as well. We've got a lot of partners who do that, but these technologies all enabled that through the evolution that we had. We also had to be able to set ourselves up to be able to do interaction with cloud-based platforms and cloud-based software that was out there. And so we had to add the ability to do web services. Web services, remote API calls in a standard way, web services were added to our platform 15, 20 years ago and are now the standard way of getting information from other software that may still be on your IBM I, or it may be out in the cloud somewhere. And we use those web services for the management that we have, the management and user interfaces that we use today, whether it's Java or mobile or HTTP, whatever, we use those services. Now let me talk to you about that one example that I wanted to mention about the input that we get from our client base. For years and years and years, of course, the most commonly used language for writing software on our platform has been RPG. It was beginning to get less and less frequent, and one of the reasons that people would do new software in RPG, one of the reasons for that turned out to be that it was very difficult for people to get programmers who knew how to do RPG. And one of the key solutions to that is to create a free format version of RPG that can be taught very easily to programmers who've never learned RPG in the past. But RPG free format never, ever popped to the top of the list of any of our advisory councils, whether it was Common Americas, Common Europe, our large user group, or our ISV. They all had things that they wanted our RPG team to do, which were higher on their priority list than free format RPG. They each had their own specific thing that they cared about more. We knew that we needed to transform RPG into something that was going to be able to be learned by new programmers much more easily. So we got all of our advisory councils together and we showed them, this is the list of the things that each of you want. Help us to prioritize what's going to be good for RPG in the future. By the time we were done with this process, in some ways it only took a couple days, in some ways it took several months as we kind of worked through this. By the time we were done, all of our advisory councils said, yes, for the good of the language and the good of the platform and for the good of the people that we represent, we need an RPG that can be taught to people who don't know the platform. We need a free format RPG. And so that allowed us to move forward with that. We knew that we were doing the right thing for the customer base, and we had gotten the customer base involved. We got a bunch of advisors who listened to what we were going to do and validated how we were doing it was going to be the right way of doing things. And so now that's allowed us to move into the modern world, where RPG is still used by well over 90% of our clients when they're doing new software. But they're doing what RPG does well, interacting with the database, doing transactions, using SQL next to it to do that sort of stuff. And they're writing software at the same time in non-RPG, but they can have programmers who have learned how to do things like node programming and PHP programming, also learning how to do RPG because those languages look so familiar, so similar to one another. But you can write the software in the language that makes sense. And so we continue to invest in new things for RPG, but we also invest in these open languages and the tools that can combine all of them together. Okay, things like Git and Yum and so on, combining them all together so that you can have that modern application. Our most recent entry into helping clients modernize is the Merlin product, which helps people who have a lot of RPG code that was written a long time ago, okay, advance that to become modern, free format, modularized RPG using tools that run in an OpenShift environment instead of tools that run on a PC, okay, but what you're getting out of that is modernized RPG that's able to be incorporated into a CI/CD environment like all the other code you're writing for other languages and other platforms. Okay, so we continue to look at what's the next thing that we need to do and where we need to create or partner with people to create new things to allow you to solve your problems. That's what we do. Same sort of thing happened when we introduced DB2 Mirror for I. We had a lot of our clients very happy with the availability characteristics of our platform. We are known as a platform that just doesn't go down. But of course, there are times, even if we have high reliability, that you're going to want to take your machine down, but people don't want to take their workloads down while they take their machine down. And so we changed the architecture of the platform to allow two instances of IBM I to mirror one another in a very synchronous real-time way, so that if you need to take one of them down for a while, you can migrate all your running workload to another system or to one of the systems and then do something to the other one without having to take downtime. It required a significant architectural change to be able to do that, but we did it because it was clearly the right thing for our customer set. Now, maybe only 5% of our customers are ever going to use this. Maybe it'll be 10. Maybe once we move to the world of cloud and mirrored cloud, it'll be 20% of our clients. But for the good of the platform, we had to get to the point where you could do this. High availability products like PowerHA, for example, are going to be enough for a lot of our clients who don't want to take downtime but can't devote 2 full systems to keeping their application environment up and running. But for many of our clients who cannot tolerate any downtime at all, this is well worth the implementation, not only the cost, but the complexity of setting up the environment. And we're making it as simple as is possible and simpler over time. All right, so we started with this layered architecture of OS 400, similar to the System 38 architecture, but not exactly the same. Okay, it has grown over time. This is the version of the architecture that I show to people now. It's almost as simple as I can make the architecture and talk about all the different things that we do as a platform. Again, you'll have the PDF for this. Don't spend a lot of time as I'm talking here trying to understand it. But we still have a layered architecture where we have things below the MI and above the MI, but almost all of our operating system has pieces that are both below and above over time, so that we can make sure to take advantage of the protection that the MI provides for us for when we need to change things in the hardware platform. So we take advantage of it as well as you taking advantage of it over time. This year, the 35th anniversary, our theme has been integrate plus innovate, right? 2 I words. Integration, because that's what we are, and innovation, because that's what clients do with what we do. And I just want to make all of you aware of the kinds of things that our customers are doing. This is just a set of 4 stories of the more than 90 stories we have out there about how clients are using IBM I in innovative ways. And all of this has become possible because of the evolution that we've done in the 35 years. Let's suppose that you are a customer who wants to automate your manufacturing using robots to do manufacturing, but you need to integrate that back to the ERP that has been running your business. It knows, what your supplies are. It knows what the things are that customers can order. All of that stuff is part of your traditional ERP that's running on IBMI, and now you want to automate your manufacturing on IBMI as well. Well, you can do that because there's open software that runs robots, that runs on IBMI, and you can connect those two things together. And we've got lots of customers in manufacturing who've done exactly that. Craftswood Group happens to be the one that's on here, but we have at least 10 stories about manufacturers who have done that with IBMI. You can do that because we brought open to the platform, because open can use our database, and the traditional RPG programs can be written and updated by people who don't know the platform for 30+ years. All of that is going on with this one customer story. What if you want, instead of using a touching interface, an interface where you have to type on a keyboard, what if you want to talk to your IBMI? Well, between us and the technologies that are going on in the world that are using web services, you can use an Alexa. Talk to Alexa. There are pieces of software from the provider of Alexa who can then create a service call that goes down and gets information from DB2, or calls an RPG program that can serve that information back up through JSON or XML, and then get told to you or presented to you on your Alexa device. And we've got a customer doing that. What if you want to not only use those mobile kind of interfaces like an Alexa, but you also want to have a machine learning chatbot that's running on IBMI and helping people do their IBMI tasks? That can be done on IBMI as well today. And we've got a customer, Brainstaff Consultants, who have helped a bunch of different schools in Japan to do exactly that. What if you want to have continuous availability? You're a bank, you're a retailer, you want to have that, and you want to be able to balance your workload across multiple platforms to take advantage of all the processing power you have. Well, that's exactly what DB2 Mirror can do, and that's what Banco GMP in Paraguay did as well. So all these advancements that we've done over time have been to allow customers to innovate while gaining all the value of the integrated, extremely forward-thinking architecture that IBMI provides. We are celebrating our 35th anniversary because we have a platform that could grow and evolve over time, and because we have a community that takes advantage of it, has learned the value of it, and has learned to love it. And I want to thank every one of you for being part of that. So now I think we've reached the end of the specific material I've prepared. I'm going to turn it back over to Tom for his polling question, then we'll see if there are any questions before we finish in the next couple minutes.
Well, wonderful job as always, Steve. Thank you for sharing this story. We do have another polling question. How can Fortra help you? Select all that apply. You want some help with document management around IBMI. You need some help with BI, data access, HA/DR concerns. We do a lot of discussions around Power HA, DB2 Mirror, and our robot HA technology. And then you want to schedule a technology update call, a briefing. I talk to a lot of CIOs that are skeptical on IBMI, and we talk about the future of it, and we do that, plus talk about Fortra. And then, of course, the free security scan. Go ahead and select any or all of those if you want. Steve, while they're doing that, let me just ask a few questions of you. Somebody asked, what happened to the Series 1? I remember Series 1. We used them at Cargill. What happened to them? And who developed them? Was it Rochester? Was it Poughkeepsie? Where did they come from?
So you're reaching back farther than I can be absolutely sure I know the answer to that question. I know I used a Series 1 to help transfer data when I was a young employee, but I don't know where it was developed. I do know that Series 1, like so many other systems that were created at that time, were created with an operating system that couldn't be moved forward the way IBMI AS400 was. And so when IBM had to make decisions about which systems that they created they were going to invest in, they eventually chose the mainframe, the AS400 and AIX, which they assumed that were going to be able to converge. And then at the time, they also had the PCs, and they were going to just settle on those. So Series 1, along with several other things, had to be let go over time.
All I remember is those little clear disk drive things that you could unstack or
Yeah.
mount into them. I don't even remember. I never used one of those myself. I saw them. Where did the Silver Lake name come from?
Silver Lake came from, so Rochester, Minnesota, where this was all developed, has one man-made lake. It's called Silver Lake. If you go into downtown Rochester and just a little ways away from there, it's a beautiful little lake that's created by a dam that we use for used for decades for hydroelectric power. Anyway, Silver Lake came from that. In fact, it got out, Silver Lake as a code name got out about a year and a half before the project came into existence. And since AS400 was going to come out in 1988, and 88 was an Olympics year, we actually had to stop using the Silver Lake name and became Olympic for about a year and a half. So that way, if anybody was overhearing us talk about things outside of work, they would no longer be hearing Silver Lake, they'd be hearing Olympic, and they'd say, oh, this is something new. It wasn't, it was just a name change.
Secretive and tricky there in Rochester. Wow.
Yeah.
Hey, if you want to do move ahead one slide for me, that would be great.
Oh, I sure, absolutely.
And while I bring up another question or two here, this is just the vast portfolio of Fortra these days. And you'll see over on the left, all of our cybersecurity solutions. 80% of our revenue today is from cybersecurity. Power tech from IBM, and then everything else that we do. And then over on the right is our automation technology that we do, Windows, Unix, and Linux. We do, enterprise scheduling, robotic process automation, network monitoring, but then everything over on the right where we get into automation of IBM, business intelligence, document management, high availability, monitoring systems, anything spool file. And then the last slide, I'll put that up, and this kind of drives home the reason for business name change is that when people heard help systems, kind of like when they hear AS400, what do they think of? AS400, they think of green screen. When they heard help systems, they would think of, oh, that nice ISV that does AS400 iSeries, maybe IBM software. And so we went with a name change. And these are all of our brands and all of the things we do across enterprise cybersecurity, from secure file transfer to security awareness training to penetration testing. And these things also reach into IBM. So for instance, we have automated penetration testing for IBM today, where we can test your Windows, Linux, Unix servers along with IBM. We can integrate into managed detection and response if you're worried about integrating IBM into the rest of the enterprise cybersecurity monitoring. We do that, and so forth. So very much so a big change here at the Fortra Help Systems Company in that regards. IBM is very important to us. We have relationships with PowerHA, BRMS, RDI. We work on those products and all of you great customers that we do business with. So it's not going anywhere. Certainly we had people ask for the slides, the recording. Those things will be available. We will have a link on our website. You should get a follow-up email. If you don't, it's because you have us blocked, more than likely, and we're in your junk mail. But certainly feel free just to email me if for some reason you don't get the follow-up email. Did you work, Steve, on the AS400 portable? I never saw one, but I heard about it in 9401-P03 according to Google.
Yeah, so I never physically worked on one. I saw them like you did. Of course, the code that I wrote went inside them, but there was no difference in the code between whatever the portable was and anything else. So, yep. I remember seeing them. They were cute.
Somebody wants to
All
know
right.
about when Power 11 is shipping.
Yeah, we aren't going to talk about that.
Okay, but we are working on it, right? I mean, fair to say that
we're working on the stuff that follows Power 10,
10.
and
It
the
might
stuff
be
that
called Power 11. It might not be,
it,
right?
it might, yeah, who knows? Who knows what people are going to call it? Yep.
Yeah, okay.
That's a
But there
marketing
is a
thing,
future, a nice roadmap, right? You guys
oh,
have roadmaps
absolutely.
out and
Yeah, we have great roadmaps, and I didn't put a
20
roadmap in this presentation. Yeah, but yeah.
and support. If you use Mimic today, does DB2 Mirror replace that?
Mimics is a solution for doing high availability, particularly disaster recovery, but you can use Mimics to do that. DB2 Mirror is a solution for continuous availability within one data center. So DB2 Mirror is trying to make sure
Yep.
that within the data center, you never have to take anything down. But it is not a high availability disaster recovery solution, because you can't have your two mirrored systems for DB2 Mirror in separate geographical locations. And that's why you need a product that's a high availability product like PowerHA or like a Mimix or something else. So they work well together to solve the
Right.
full availability story, right?
Yeah, I would look at DB2 Mirror as your high availability, because it's active systems in a
Yes.
very close niche data center, whereas a tool like Mimix or Robot HA or Power HA, those tools are going to be your disaster recovery part of that solution, where they can replicate, and iCluster, yes, somebody put iCluster in there, where we can replicate data from the on-premise environment to somewhere else in the globe, so that you have a true disaster recovery environment. And
Yep,
those
that's
are with a switchover time, right? You're looking at 30 minutes, an hour, depending upon how complicated your environments are.
exactly. And that when I talk about high versus continuous, a high availability product is the right thing for so many of our clients who are okay with being down for a couple of hours when they have to do a switchover. But
Yeah.
there are clients who need continuous, and that is very difficult to do unless you've got a product that was specifically designed for that, and that's what DB2 Mirror is for.
So really we should change the phrase continuous. HA and DR is really what the three levels
That's sort
of
of,
availability are, right?
yeah,
But people don't
that's the
talk.
way it feels to me. Yeah,
Yeah, people use HA, DR interchangeable. But
exactly.
anyways, well,
Yeah.
we are
Well, I think,
almost up with time. We've exhausted our questions. I want to thank you again on behalf of Fortra, Steve, for joining us. Have safe travels throughout the rest of the year. I'm sure we'll catch up with you somewhere on the road. Good luck at the Ocean User Conference coming up.
thank you.
And thank you to all your to all the customers that have joined us. I should say your customers, and they are our customers too, I hope. So we'll talk to you soon. Have a great rest of summer too.
All right, bye-bye now.
Bye-bye.